Now, using the same graph as before, previously I didn't talk about the function, but now I am, because instead of giving a function, instead of giving a graph, what happened if you were just given the function and you would have to tell me the end behaviors? Well, here you have two even functions because they're both going in the same direction. Now, since you can see the graph with the function, we're going to talk about the properties of it. So, on the top where it says LD, that's leading degree, and LC, leading coefficient. Now, leading degree means the greatest or the highest exponent within the function. Leading coefficient is the coefficient or the number in front of x with the highest degree. So, if you're given a function and you're talking about in behavior, first you have to find the leading degree. So, in here, we have 2 degrees, 4 and 2. But we're mainly going to focus on the greatest one, or the highest one, which is 4. Same thing here. We have 2 exponents, 4 and 2. But again, leading degree, the greatest exponent or the highest exponent, which is also 4. Knowing what type of exponent you have, even or odd, can tell you where the end behavior starts, where it's going. So let's look at the one on the left. So we have leading degree of 4. The leading coefficient is a positive 1. But we're not going to focus on the number, we're actually going to focus on the sign, which is positive. Now the reason we're going to focus on the sign of it is because, as you can see, positive coefficient, even degree, is going upwards. Now this applies is if the leading degree is 2 or 6 or 8 and all the other even degrees. Same thing over here. Now, let's take a look at the leading coefficient here. It's a negative 1, but we're going to focus on the sign of it, which is negative. And as you can see, it's going downwards towards negative infinity. So, even degrees, which we have here, meaning that they're both going in the same directions, but on the left, it's a positive coefficient, so it's going upwards to positive infinity. Or should I say, f of x approaches to positive infinity. Over here on the right side, even degree, but the leading coefficient is negative. So that means that it's going downwards, or f of x approach to negative infinity. So these two are examples of even functions with positive coefficient and negative coefficient. Now we have 2 odd functions because we can see that both ends are going in opposite directions. And let's take a look at the leading degree in both functions. Even though we have 2 exponents, we're going to look for the highest, which is right here, 3. Over here we actually have 3 exponents, 3, 2, and invisible 1. But again, we're going to look for the highest, which is 3. So both of them has the highest exponent of 3. 3 over here, 3 over there. Now, the concept still applies if the exponent is 5. Well, leading degree, leading exponent is 5, 7, 8, and so on. Now let's look at the leading coefficient on the left. As you can see, it's an invisible 1. But again, we're going to mainly focus on the sign, which is a positive. On the right, you can see it's a negative 1. But again, we're going to mainly focus on the sign, which is negative. Now, let's take a closer look at the graphs. As you can see, if it's a positive coefficient on the leading degree, it's going to start at the bottom left or going towards negative infinity. And on the other side, it's going to go towards infinity or positive infinity. But let's take a look at the one with the negative coefficient in front of the highest degree. Since it's negative, we can see that on the left side, it's going towards positive infinity. On the right side, it's going towards negative infinity. So there's a pattern. Odd function, regardless if it's degree or exponent of 3, 5, 7, 9, or even 11, so on, it's going to go opposite direction. So that means one side is either going to negative infinity and the other side is going to positive infinity, or vice versa. So here, when the coefficient right here in front of the leading degree is positive, the left side is going towards negative infinity, the right side is going towards positive infinity. Now, if your leading degree, again, is odd and it's negative, your leading coefficient is negative, then the left side is going towards positive infinity and your right side is going towards negative infinity. So again, if you were given the functions only, the equations, but no graphs, you have to remember, for odd function, positive coefficients, left side, negative infinity, right side, positive infinity. Negative coefficient, left side, positive infinity, right side, negative infinity. Okay, here I made a chart of the end behaviors for when x approaches negative infinity, which is the left side, and x approaches infinity, which is the right side. Now here it says even leading degree, the highest exponent, and here is the odd leading degree, odd highest exponent. And then depending on the leading coefficient, if it's positive, these should be the end behavior for the left side and the right side for an even function. If the leading coefficient is negative, those are the end behavior. Same thing here. If the leading coefficient is positive, these are the end behaviors for left side and right side. Now you can copy this into your notes, but it's best to memorize it when it comes to quizzes or tests, especially when you're taking future math classes. Now, our first example is f of x equals 3x to the 7th power minus 5x to the 4th plus 3x squared minus 6. Now keep in mind that sometimes you might not have a function where the exponents are in order from greatest to least. If it's not, all you have to do is look for the highest exponent, or also known as leading degree, and then look at the leading coefficient. So this one is the highest exponent, so I'm mainly going to focus on this leading coefficient. So since the highest exponent, leading degree, is odd, we're going to focus on this side. Since the leading coefficient is positive, we're going to look at this. So as x approaches negative infinity, the left side, f of x should approach negative infinity. So I'm going to write negative infinity here. Now x approach infinity, which is the right side, then f of x approach to infinity or positive infinity. So that's all you have to do when you're given either these two questions and then given a function equation. Now, if I were to ask you for limit notation, well then you just mainly use this information. So let's do the limit notation for the left side. So I would write the limit of f of x, because that's what it is right here, f of x. Let me write that bigger for you. The limit of f of x as x approach to negative infinity or the left side equals to negative infinity, which is right here. Now the limit for this one, limit of f of x as x approaches to infinity, the right side, then it will equal to infinity, or positive infinity, which is this one right here. So if I don't ask you for limit notation, then this will be one of your answer for the left side. This would be your answer for the right side. Now if I ask you for the limit notation, say for the left side, this would be your answer. If I ask you for the right side, then this would be your answer. For example 2, now the exponents are in order from greatest to least. So we're just going to focus on this one and then look at the leading coefficient. So since the highest exponent is even, we're going to focus on this side, and the leading coefficient is negative, so these are the two in behavior we're going to focus. Now for x approach to negative infinity, the left side, then f of x will approach to negative infinity. And then as x approaches to infinity, the right side, then f of x will also approach to negative infinity. So again, if I were to just ask you to give me the end behavior of the left side, this would be your answer. If I was just asking for the right side, this would be your answer. Now say I ask you for limit notation. So if I were to ask you for limitation of the left side, I would write limit of f of x. Again, I use f of x because that's what's given, as x approach to negative infinity, the left side, then it will equal to negative infinity. Now if I were to ask you for the right side, so limit of f of x as x approach to infinity, the right side, then it will equal to negative infinity. So here's the limit notation of the left side, and here's the limit notation of the right side. So again, if I were to ask you for limit notation of the left side, this whole thing you would give me. If I were to ask you for the right side, you would write this whole thing right here. In our third example, we have f of x equals negative 4x to the fifth plus 6x squared minus 3x to the seventh power minus 8x. Now here, the exponents are not in order, but again, leading degree means highest exponents. So we see that the seventh is the highest exponent, so we're going to focus on the leading coefficient minus 3 or negative 3. So the highest exponent is odd and it's a negative coefficient, so we're going to look at this. So as x approaches to negative infinity, the left side, then f of x will go towards infinity. As x approaches to infinity, the right side, then f of x will approach to negative infinity. So this would be my answer for the left side, this would be my answer for the right side. Now again, if I ask you for limit notation, I would just write the limit of f of x as x approach to negative infinity, equal to, which is this, to infinity. That's the limit notation for the left side. Now for the right side, limit of f of x as x approach to infinity, then it will equal to negative infinity. So here's the limit notation for the left side, here's the notation for the right side. Now keep in mind to take a closer look at the bottom part. That's where you'll be able to tell which one you're doing. Left side, right side. In our fourth and last example, we have a function f of x equals 5x squared minus 7x to the third plus 4x6 minus 2. Same as the last one, the exponents are not in order from greatest to least, so all I have to do is just look for the leading degree or highest exponent, which is right here. So we're just going to focus on the leading coefficient. Our highest exponent is 6, so that's even. Positive leading coefficient, so this one right here. So for the left side, as x approaches to negative infinity, f of x should approach to infinity. For the right side, as x approaches to infinity, f of x will approach to infinity. Now, these two would be the answer if I just ask you for the left side or the right side. Now, limit notation. So, the limit notation for the left side would be limit of f of x as x approach to negative infinity equal to infinity. Now the limit for the right side would be limit of f of x as x approach to infinity, it will equal to infinity. So here's the limit notation for the left side, limit notation for the right side.